everyone. So, hi, Coco. Is that good? Thanks. Okay, let's talk about what's happening, and and I'll tell you what's going on today. Good to see y'all. Happy Tuesday, everybody. Okay. Oh, that was Grace. Grace did that. It was actually a skeleton, did it? No. Once again, if you're watching this at home or if you're watching this on a video, again, Thursday and Friday are going to be the actual tests. And I talked to Dr. Lippy today about our schedule for Friday. Friday is the Halloween costume contest. He said they don't have it settled down for sure yet, but it's most likely going to be 20-minute class periods, and that's going to be fine. So I want you all to understand that Thursday's test will be a little beefier than it was before. Okay, y'all with me on this? Everybody listen here. Thursday's test will be a little bit beefier. Okay, I don't need time at the end of class to grade them to make sure like that, you have, to tell you who got a perfect and who didn't get a perfect. Okay, I'll just be able to pick those up. So it'll be a little beefier on Thursday, so we can ensure that Friday we have enough time. Okay, and I think we should be fine. Even with 20 minutes, I think we should be totally fine. Okay, so that's Thursday and Friday. Okay, so today what I want to do is I want to talk just for about 10 minutes or so here about some bone stuff. Okay, and then I'll give you some time if you want to look at bones, if you want to practice bones, if you have questions. Okay, I know some people were helping some other people online. If you guys, anybody at home wants to look at some bones, I'd be more than happy to have somebody bring up their bone and show you that. That's totally up to you. Okay, but just give me a few minutes here to talk some bone stuff, and then I'll give you some time to study. Okay, any questions before we get going? Okay, here we go then. Let me get my mic on so you can hear me. All right, so we've been talking yesterday during Med Talks. We saw the picture of that dude, or sorry, it was more, I think it was a woman. Yeah, 69-year-old woman who her fingers were pulling apart like that. Remember that from yesterday? Super cool stuff. And if you remember, that all had to do with osteoclasts. Okay, so osteoclasts break down bone. And I love talking about osteoclasts because it's a nice segue into talking about muscles. And so starting next week, we're gonna hit the muscles hard, and we will do muscles from now until the end of the semester. Sorry, geez. Is it Dylan? Hey, Dylan, sorry, man. That timing was a bummer. All right, so we talked about osteoblasts. Remember, those are bone babies. These are bone cells, okay? And then yesterday introduced that idea of osteoclasts, those things that break down the bones. Why on earth do we need to break down bone? I thought we wanted bone to protect us. I thought we needed bone to make blood. We also need bone as a source of calcium. Yes. Yeah. Okay, sorry. I was on your wavelength, dude. So these are all coming from the marrow. So these osteoclasts originate from the stem cells. And remember, stem cells are the cells that become other cells. So you should maybe remember this from either AP Bio. Is anybody in AP Bio right now or took AP Bio? Alexa, you guys took AP Bio last year. Did you guys talk much about stem cells? A little bit, yeah. So has everybody heard of like somebody getting a stem cell transplant? Yeah. I have a friend who has a disease called adrenoleukodystrophy. It's the same disease that Lorenzo had from Lorenzo's oil. Right. Guys, if you took my Bio 1 class, we watched Lorenzo's oil. It's a tearjerker, makes me cry every time. Okay, genetic disease typically happens in boys, but now can happen in girls. Yeah. Yeah, so CRISPR is like real cool. CRISPR is kind of like one of those things where we can manipulate like DNA and make it do stuff for us. For sure. Okay, so these osteoclasts, you're like, why would I want to break down bone? Well, I need that calcium. And so you're going to find that you will not be able to move your muscles at all if you didn't have calcium, because there's these fibers called myosin, these other fibers called actin, and they need to bind together. And if those don't bind together, you're not moving. Okay, the only way to bind those together is to remove something called troponin. And what removes that is calcium, moves it out of the way so these things can bind. I'll tell you more about this later. Okay, but we're not talking about like serious chompage of bones so that you can't walk or move or your bones become brittle. Okay, right now, there are several of you in this room that have osteoclasts that are chewing away at your bone, okay, and releasing calcium into the bloodstream. Okay, if you've ever, like, I want you to try this tonight, okay, like when you're falling asleep, okay, if your room is really quiet, if you close your eyes, you can actually hear the osteoclasts going, okay, they actually are eating, sorry, I can't, not true, it's not gonna happen. Okay, anybody here, Mr. Obvious? Anybody know Mr. Obvious from the Bob and Tom show? Bob and Tom show. There's a great one about a guy who believes his animal, there's an animal in his sink. And he said it's really weird because every time he turns the light on, the animal gets real angry. And he said one time he tried to put his hand down the sink to grab the animal, kind of bit his fingers. Well, he wasn't talking about the animal. He was talking about the garbage disposal, right? Yeah, he turned it on. It's a pretty funny skit. Anyways, okay, osteoclasts, you're not going to hear those, okay? But right now, somebody's bone is being chewed away because you need that calcium level, and hormones do that. Okay, so here's another little quick reviewsies. Okay, here's our bone cell. Here's these canaliculi. Do you remember what the name, think Lion King, this little cave? Lacuna. There it is, right? Good job. I asked the last class, they're like, I don't know. And there it is. So this little cave is the lacuna, Lacuna Matata, right? Okay, so that's where that osteocyte lives and hangs out. But I want to look more specifically at what's inside that bone. We looked at the spongy bone. Remember from the surgery that the surgeon pressed down on that spongy bone, that Cancell's bone, to test the compressive strength, to see if that bone, that inner bone, could hold, okay, the prosthetic. And so we got to see that. And of course, it was all bloody and crazy. Okay, but what about the outside of the bone? Okay, how is that different? That compact bone. Well, this is what you saw on your tots, right? On your tots, you had a picture that looked like this one right here. Okay, with these kind of looks like a tree stump, right? With the rings, okay, and then the middle. Okay, those rings are actually, the circles are called osteons, but I want to look at it close up. So here's my femur, there's the greater and lesser trochanter. Here's the compact bone on the outside. If you notice, there are these red and blue lines. Now, way back a while ago, I told you that if in an anatomical drawing you see red or blue, that means something. What does the blue mean? Yeah.
I'm just gonna go with
yeah.
Obvious, but veins.
Veins, you're exactly right. Veins, and what do you think the red is? Okay, nice guess. Arteries, you're right. So the red is arteries, the blue is veins. Now remember, there's no such thing as blue blood. You can look at your wrist, okay, you can see it, like, sure enough, looks blue, okay, but you're just looking through layers of skin. It's like looking out that window, okay, in the back of my room, I see the bus, okay, but the bus is a different color than if I just step over here and look out the window through the greenhouse. That's a brighter yellow. This is a kind of darker yellow. That's because that window's tinted. Okay, that window's not tinted, but even if I go outside, it's going to be even a more brighter, okay, color yellow. All three yellows would be different, right? Okay, it's not true that you have blue blood. I've also heard that if you cut yourself, okay, the oxygen hits it. Sorry, I was chuckled this, and then instantly turns it red, right? Okay, it's blue until oxygen hits it. Okay, that's not true. It would be awesome though if you cut yourself and like you look for like the flash of blue before the oxygen hits it and turns it red. You know what I mean? Like, wouldn't that be cool? But not true. That's not, yeah. Okay, if you cut yourself and the blood is really dark, you've hit a vein. If you cut yourself and it's bright red, that's an artery. Okay, and I don't know if you've ever experienced that before, but I've definitely cut an artery and I've definitely cut a vein. And you could tell the differences between those because of that brightness in color. When we watch the gallbladder surgery, by the way, the person who is doing the gallbladder surgery dies in the middle of it. It's horrible. Okay, but we'll watch it. Okay, and there's a part where the doctor cuts an artery, and you can see the pulse of the blood like squirting, okay, through there. So it's pretty exciting. Maybe somebody will pass out.
What caused him to die?
Okay, man. I mean, it's sad, but gallbladder surgeries. A lot of people die from complications. There's a man in North Manchester just recently that passed away from it bad. In this case, it was sepsis. So the infection in the blood. Yep. Okay. So your bone is alive. This cell's alive. This cell's alive. That cell's alive. If cells are alive, they need to do their job. So they need to go through cellular respiration. They need oxygen, right? They need glucose so that they can break things down inside there. There's a nucleus inside each one of these little cells, right? So how do we do that? We transfer that, to those bones. And we also, remember, we need to take this blood, and send it out to the rest of the body, because this is where, your bone is where blood is being made, right? Okay, so these blood vessels are connected up here throughout this bone marrow area. Okay, so that's an osteon, and all these holes through the middle are where those blood vessels are located. Okay, it's a pretty genius design. Lots and lots and lots of layers. Okay, I want to talk about this real quickly. I want to. Someone left me. Oh. Oh man, there's a serious chat going on here I'm missing. Sorry, I got distracted by all the chats, you kids, the ringing noise. Okay, sorry, Hope. Rona. What? Is there a ringing noise? Somebody talk to me.
I think he meant like the ringing noise when you were talking about the osteo class eating away.
I thought you were having trouble with the sound. Does it sound okay today?
Yeah.
Indeed.
What's that?
Yes.
Thank you. Matthew, by the way, likes to talk in wingdings.
Yes, wingdings. But I was talking about so when you're talking about when everything goes silent, you can hear a ringing. You hear like a noise. Is that that ringing noise you hear like when everything's silent?
No. Great question. But
So then what's the ringing noise?
we'll talk about that later when we get into the ear.
Oh, okay.
Word up.
Because all I know from what my parents telling me is that's the sound of your blood flowing through or something along the lines of that.
Sometimes you can hear your pulse in your ear, right? That throbbing.
Yeah. I've had that happen to me before. It's very uncomfortable.
Right. Oh yeah, it's no fun. Okay, I think I'm going to stop there. Okay, we'll talk about endochondral ossification later. I'm going to give you the rest of the time to either look at your bones or look at bones online. Okay, I'm going to stop recording here for a quick second.